Hi, my name is Mr. Chu and welcome to my study room. Today I'm solving objective questions 7, 20, 24, 31 and 40 of the 2023 WASSCE General Mathematics paper written by Ghana. And question 7 reads that the angle of elevation of the top of a vertical pole from a point P on a level ground is 60 degrees. The distance from P to the foot of the pole is 55 meters. Find the height of the pole. As I do with most of my lessons, we'll start by identifying the key points in this lesson. And the first one is the angle of elevation of the top of the pole is 60 degrees. And where we are getting the angle of elevation from is the point P on a level ground. And the next information we can get from the question is the distance from P to the foot of the pole is 55 meters. And then the last one is the height of the pole, which is what we are solving for. Obviously, this question is an application of trigonometry or trig ratios. Because of that, the diagram of the question will be in the form of a right triangle. Because of that, we'll sketch quickly, then we go ahead to solve the question. Right, so this is our vertical pole. Let me just try designing something. Alright, so I just try to sketch it as much as possible. So this is our vertical pole. Let me shade it. And then the question says that the angle of elevation of the top of a vertical pole from a point P on a level ground. So P will be here. And this angle of elevation is 60 degrees. So our 60 degrees is going to be here. This is the angle of elevation. And then the distance from P to the foot of the pole is 55 meters. So this is the foot of the pole. And then this is P. So 55 meters will be here. And the question is find the height of the pole. This is the height of the pole. Let's call it X. Right. Yeah, like I said from the beginning, this is an application of trigonometry or trig ratios. So we're going to use SOHCAHTOA to solve this question, and we need to identify the parts that we need so that we will know which of them to use. And from here, if we are using this 60 degrees, then this side of the triangle is going to be the opposite, and then this side is going to be the adjacent. And looking at SOHCAHTOA, we will need a ratio that has the opposite and the adjacent in it, and that is tan. So we'll be using this to solve our question. So now let's have our setup, which will be sine of the angle, which is 60 degrees, be equal to opposite is x divided by adjacent, which is 55. And by multiplying both sides by 55, we're going to have 55 sine 60 equals x. And looking at the possible answers here, meaning that we don't want the answer in decimals, but rather in the third form. So that will make me break this one down to be 55. And then sine 60 is root 3 over 2. And that will be equal to x. Comparing that with this, then our answer is going to be 55 root 3 divided by 2. That is our x. And looking through the options, that's going to be option B. Or for those of us using calculator, that's going to be approximately 47.63. So this is what you are going to do. If you are not able to break sine 60 to get root 3 over 2, then this is what you can do. When you plug this into your calculator, all you have to do is that you are going to compare each of the options here to the answer you got, which is 47.63, and that will be your final answer. Because of the answer here, whatever your calculator gives you for this, you have to plug each of these into your calculator, and the one that will be equal to your answer becomes the correct solution. We move on to the next question. Question 20 reads that one side of a gutter is 15 centimeters lower than the other side. A plank of wood which is laid across the gutter to form a bridge slopes at an angle of 35 degrees to the horizontal. How wide is the gutter? Let's identify the key facts from this question. That's the fact that one side of a gutter is 15 centimeters lower than the other side. A plank of wood which is laid across the gutter to form a bridge slopes, so the plank slopes at an angle of 35 degrees to the horizontal. And then the main question is, how wide is the gutter? Again, because this question is an application of trig, it will be advisable for us to sketch our diagram, which will be obviously be a right triangle. Okay, so I take this to be our gutter, which is maybe has a square corners at the base instead of circular base. Then this is one side of the gutter and this is the other side of the gutter, and I choose to call the first side of the gutter S1, and then I call the second side S2. And the question says that one side of the gutter is 15 centimeters lower than the other side, so it means that this side of the gutter 15 centimeters. So from the end of the second side of the gutter S2 to the end of the first side S1 is 15 centimeters. Then the question went on to say that a plank of wood which laid across the gutter to form a bridge slopes at an angle of 35 degrees to the horizontal ground. So this is the ground, and then this is our plank, and then the plank and the ground form an angle of 35 degrees. All right, and the question is, how wide is the gutter? So this is how wide the gutter is. This side will be how wide the gutter is. So let me just put X here to show how wide the gutter is. And now again, we know to be able to solve this question, we need to know the three basic trig ratios, which is SO, Ka, and Tua, where SO is sine means opposite over hypotenuse, Ka is cos or cosine means adjacent over hypotenuse, and then Tua is tan or tangent means opposite over adjacent. So we need to identify the size of this triangle so that we will know which of them to use. So the first side that is given is the 15, and that is the opposite side of the triangle because it's facing the or directly opposite the 35 degrees. And then the side that connects the angle and the hypotenuse is the adjacent. So this is the adjacent side of the triangle. That means we're going to use the ratio that has opposite and then adjacent, and that is 2r, right? Because of that, our setup is now going to be tan 35 equals 15, which is opposite over x adjacent. By cross multiplication, we're going to have x to be equal to 15 over tan 35. And when we plug that into our calculator, it's going to be approximately 21.42 centimeters, which is option C. We get on to the next question. Question 24 says that given that tan x equals 12 over 5, find the value of sine x cos x. First of all, as we just saw in question 20, the tan of an angle is opposite over adjacent. So it means that taking this to be a right triangle, if this is x, then it means that the 12 is here and then 5 is here, and then now we need to solve for this side. And with that, we're going to use Pythagoras theorem to solve, which will be x squared equals 12 squared plus 5 squared. X squared will be equal to 144 plus 25, and x is going to be square root of 169, which will be 13. So this side of our triangle is 13 units. Good. Now that we know this, sine x is opposite over hypotenuse, and cos x is adjacent over hypotenuse. Tan x has been given us in the question already, 12 over 5. Sin x will be opposite, which is 12 over 13, which is hypotenuse. Then cos x is adjacent is 5, hypotenuse is 13. Alright, so we're just going to plug this into this and the solution becomes our answer. So let's do that quickly. So sine x cos x is the same as sine x times cos x. So that becomes sine x is 12 over 13 times cos x is 5 over 13, and that will be 60 over 169. And looking through the options, that is option D. We go to the next question. Question 31 says that a point on the ground is 5 meters away from the foot of a vertical wall 12 meters high. Calculate, correct to the nearest degree, the angle of depression of the point from the top of the wall. Let's underline the key facts from this question. And the facts are that a point on the ground is 5 meters away from the foot of a vertical wall which is also 12 meters high. And we have to calculate to the nearest degree the angle of depression of the point from the top of the wall. This is an application of trig, so the diagram will be in the form of a right triangle. Because of that, we'll go ahead and sketch the right triangle before we start solving. Now we have a presentation of the problem here, and they said the point is on the ground. So let me make here our point. Let me call it P for point. And the question says that point is 5 meters away from the foot of a vertical wall. So let me take this to be my vertical wall, and then mean that from the foot of the wall here to the point is 5 meters. So I put 5 meters here. Then the question said the wall is 12 meters high, so this is 12 meters. Then the question says you calculate, correct to the nearest degree, the angle of depression. So the angle of depression is someone is standing on top of the wall and looking at P. So it will be here, which is theta. The actual angle of depression is supposed to be here. But then this angle and this angle are alternate interior angles, so they are equal. Because of that, we're going to use this because it falls within our triangle. So we are doing the same thing we did for the past 3 questions also. So this side of the triangle is the opposite and this is the adjacent. Because of that, we are going to use TOA, which involves the use of opposite and adjacent. So the setup is going to be tan theta, which this time we don't know, equals opposite is 12 divided by 5, which is the adjacent, and theta is going to be tan inverse of 12 over 5. And when we solve that with our calculator, we're going to have theta to be approximately 67.38 degrees. But because the question says we should calculate to the nearest degree, theta will finally be approximately 67 degrees. And looking through the options, that is option D. Then we move on to the last question for this study, which is question 40. Question 40 says that a chord of a circle 12 centimeters long subtends an angle of 150 degrees at the center of the circle. Find the radius of the circle. The key fact from this question are the fact that the chord is 12 centimeters long and the subtended angle is 150 degrees at the center of the circle. And we have to calculate for the radius of the circle. Again, it will be more appropriate for us to sketch the diagram to this problem. So that is what I will do first. Alright, so this is our circle with the chord of 12 centimeters. Then they said this circle subtends an angle of 150 degrees at the center. So this is 150 degrees. Then we have to find the radius of the circle. Since this is the center of the circle, let's call it O. Then this is going to be the radius of the circle. This side also radius of the circle. Let's call it R. Right. So this triangle here, maybe let me call it here A and then here B. Triangle OAB is an isosceles triangle. Why are we saying that? Because it has 2 equal sides. Because of that, a perpendicular line drawn from the center of the circle to the chord AB is going to be a perpendicular bisector of chord AB, meaning it divides the chord into two equal parts and also bisect this angle because the triangle is an isosceles triangle. So we can now have this side to be 6 centimeters and then this side to be 6 centimeters, and also this is going to be 75 degrees, which is half of 150. So taking any of these two triangles, which is a right triangle, we can just use SOHCAHTOA to work it out. So taking this angle 75 degrees here, this side becomes the opposite and this side is the hypotenuse. So because of that, we can use sine to solve for r. So the setup is going to be sine 75 equals opposite is 6 divided by r, which is the radius or the hypotenuse. Cross multiplying, we are going to have r to be equal to 6 divided by sine 75, and that will be approximately 6.212. By looking at the answers here, since they be rounded to the nearest tenth or 1 decimal places, that's going to be approximately 6.2 centimeters. So looking through, it means that the correct answer to the question is D, which is 6.2 centimeters, and that is the radius of the circle. And that is where we bring today's study to an end. I hope this lesson has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Till we meet again in my study room. Bye bye.